Hello and welcome back to Monday, March the 30th, and I'm going to go over the answers that were to the questions that were given on Friday. Hope everybody had a productive weekend and is staying up with your lessons. Like I said before, I know it's been giving me a sense of routine to think about these questions and to see your responses. So thanks to everybody who's been staying up and doing these daily assignments. I think it's really good for us. So let's go ahead and go over the answers to the questions on Friday. So here's number one. It says what number is halfway between 3/7 and 6/7? Express your answer as a common fraction. Okay, there's a couple of different ways you could go about doing this. So one way you could do it is adding the two fractions together and then dividing by two, because that's kind of what an average is, the number in the middle, right? So since there's only two fractions, we could take the two fractions and say 3/7 plus 6/7. Since they already have common denominators, we can go ahead and add the numerators, keep the denominators the same. Our answer would be 9/7. Okay, so now what we need to do in order to find the average is divide that by 2. Now, fifth graders are already fluent, hopefully, in dividing fractions, but if you take 9/7 and you divide it by 2, and we know that 2 is the same thing as 2 over 1 as a fraction, we can also say that 9/7 times 1 over 2 is the same thing, because remember, dividing by a number is the same thing as multiplying by that number's reciprocal. So what we do is we switch the places of these two, and it's called the reciprocal. And what you get over here is 9 over 14, and that would be our answer. Okay. Another way you could have thought about this, I was thinking, is, well, halfway between these numbers. Well, there's a difference of 3 between 3 and 6, and half of 3 is 1.5. So interestingly, it would give us a fraction numerator, right? So halfway between these two numbers would be 4.5 over 7. Now we can't leave it like this, right? So how would we get rid of that half? Well, what we could do is multiply this fraction by 2, okay? So what we could do here is um, we're going to multiply, both fractions, or the numerator and the denominator, by 2, and that will get us out of that half, right? So what we're going to do, and multiplying the numerator and the denominator by 2 is the same thing as multiplying by 1, and you can multiply any number by 1 and still get that number. So we're still going to multiply it by 2 on the numerator and denominator. Well, 4.5 times 2, that is 9. And 7 times 2 is 14, which gives us the same answer that we got earlier. So, all right, so there's the first one. Go ahead and go down to the next one. It says that George has 5 ribbons, each 4 feet inches in length, 4 feet 8 inches in length. What is the combined length of George's ribbons? Express your answer to the nearest foot. There's a couple ways you could do this. Let's first take 5 ribbons, and we're just going to figure out how many whole feet we have with our 5 ribbons. So if we have 4 times 5, that's going to give us 20 feet. Okay, now let's take the 8 inches, because each one of them has 8 inches on the ribbon on top of the 4. So we could take the 8 inches. Now let's go back here for a second and make sure that we label this as feet so we don't lose track. Now we're going to take those 8 inches also times 5. Okay, and that's going to give us 40 inches. Okay, well, we have to express this answer in feet. So let's convert the 40 inches into feet. Well, we do that by dividing by 12. And if we take 40 divided by 12, we get 3, with a remainder of 4, which would mean that it's 3 feet 4 inches. So if we add the 3 feet 4 inches to the 20 feet, that would be 23 feet and 4 inches. Okay. Well, if you round that to the nearest foot, that is less than half of a foot, which means that your answer should be 23 feet. Okay, another way you could have done it is just converted the whole thing into inches, multiplied by 5, and then divided by 12 in order to find out how many feet that is. Give me a second here to erase. And let's go ahead and do that. So if we take 4 feet 8 inches, 4 feet times 12 is 48. Okay, and then you add the 8 inches. Okay, that would be 56 inches per ribbon, okay? But he's got 5 of them, so we're going to multiply that by 5. All right, when you multiply those two, you get 280. Now to convert that back into feet, you're going to have to take 280 and divide that by 12. Now 12 goes into 28 twice. 2 times 12 is 24. Get a difference of 4. I'm going to bring that 0 down. I know that 12 goes into 40 3 times, and that gives me 36 with a difference of 4. So that becomes 23 feet, 4 inches, and that looks a lot like what we just got in the last problem. And once again, that would round to the nearest foot to 23, okay? All right, moving on. Let's take a look at this next one. It says a math club for 7th and 8th graders starts with 14 7th graders and 8 8th graders. Each week, 3 new 7th graders and 4 new 8th graders join the club. What will be the total number of members when the club has an equal number of 7th graders and 8th graders? Love this problem. Okay, so let's go ahead and make a table. And this would be kind of more the brute force method, but that's okay. This works for us. We're going to go ahead and say that this column is going to be 7th, this column is going to be 8th, and then this column is going to be like week number. So at the start, or we could actually call it week 0, the 7th graders had 14, and the 8th graders had 8. Okay. All right. So I didn't leave myself enough room here. Okay, week 1. I'm going to try to write smaller. Pull it up just a bit. Okay, week 1. 7th graders, it says, increases. Each week, the 7th graders increase by 3, and the 8th graders increase by 4. Okay, so let's take a look at that. Each week, we're going to add 3. So in this one, week 1, you're going to have 17 7th graders. We're going to add 4 to 8, and we're going to have 12. Okay, week 2, we're going to have 20 7th graders, and we're going to have 16 8th graders. You can see that the 8th graders are slowly catching up with the 7th graders. All right, moving on. 3 would be 23 7th graders. That would be 20 8th graders. Week 4 would be 26 7th graders and 24 8th graders. All right, week 5 would be 29 7th graders and 28 8th graders. Oh, we're so close. We're only 1 student away from being equal. So if we go down to 6 weeks, it would be 32 7th graders and 32 8th graders. And there we go. Week 6, we would have 32 and 32. And the question is, how many students would there be total? So you add those two together, and you get 64 students. There's an algebraic way, and I just want to show you really quickly how that would be solved, because the brute force method works up to a point, but when the numbers start to get a lot more complicated, it's always a good strategy to have an algebraic approach. So let's go back here. Let me write this as an equation, okay? So I want the number of 7th graders to equal the number of 8th graders? Okay, so let's do that. Let's write an equation that for every week, we're going to add 3 new 7th graders. So watch this. I'm going to say 3. That's how many they get in addition each week, times the number of weeks. This is 7th graders, plus the 14 that you start with. Okay, now I want that to equal the number of 8th graders. Okay, so in this case, it's going to be 4W plus 8, because we started with 8 students. Each week we increase by 4. So watch me do this. I'm going to get my W's over on the same side. How do I do that? I subtract 3W. If I subtract 3W from this side, I just get W, which leaves me with 14 equals W plus 8. Okay? Now, I'm going to get the 14 over here. Well, if I subtract 14 from this side and I subtract 14 from this side, that leaves me with, I have to squeeze this in down here, that leaves me with 0 on this side. Since there's nothing left on that side of the equation, 0 equals W minus 6. Okay? Now, what's going to make this true? What would W have to equal in order for for this side to equal 0? Well, you would have to have 6, right? Because 6 minus 6 is 0, which means that W equals 6. But that's not the answer. That's how many weeks it would take to get to this point. So we're going to solve both of these back in the original equation, both sides, to see how many students there are in that week. So if we take 3 times 6 plus 14, and the next one we take 4 times 6 plus 8, okay? That should give us the answer. So here is 3 times 6 is 18, plus 14 is 32. Well, that's good. 4 times 6 is 24, plus 8 is, look at that, 32. And we have the same answer of 64. Once again, it was easy to do this brute force because there's only going to be six different iterations. But if this number were to be a lot bigger, the algebraic approach certainly is the way to go. All right, what is the product of the least common multiple and the greatest common factor of 10 and 15? Well, let's take a look at that. What is the LCM, which we call the least common multiple of 10 and 15? Meaning, if you multiply 10 by different numbers and 15 by different numbers, when's the first time that they're going to share the same number? Well, I'm going to count by 10s. 10, 20, 30. So if we also count by 15s, we get 15, 30. The LCM for 10 and 15 is 30. Okay, now we need the greatest common factor, meaning the biggest number that goes into both 10 and 15. So the GCF is 5. Now I need the product of these two. I'm going to multiply 30 by 5, and I get 150. Right? There is the product of the least common multiple and the greatest common factor of 10 and 15. All right, moving on to science. All right, kind of enjoying these volcano problems since we do live so close to a volcano and Washington has such awesome geology. It says, why are some volcanoes cone-shaped and some shield-shaped? Well, Mystery Science explains to us that cone-shaped volcanoes have thick lava that oozes out slowly, forming a hill. The shield-shaped volcanoes have lava that is thin and runny, so it spreads out a lot more and further, which gives it the low, rounded shape as opposed to the cone shape. Okay, next, if you were traveling and found a volcano, how could you figure out if the volcano makes felsite or basalt lava? Remember, the felsite, right? That is the thin stuff. That's the stuff that oozes out, that comes out very quickly, and the basalt lava cools very slowly, okay? Well, relative to the felsite. So you could look at the shape of the volcano and the color of the rocks. If the volcano is shaped like a shield, more rounded and low, and the rocks are dark, which means that they're basalt, the volcano probably produces basalt lava. If the volcano is shaped like a cone and the rocks are lighter in color, like a light gray, the volcano produces felsite. Okay, so I can't, other than the surface flows in eastern Washington, we don't really have many other shield volcanoes that I would consider in Washington state. Oh, sorry. Back to my cursor. Which volcanoes are more likely to explode? The ones with thick lava or thin lava. Why? What evidence do you have? It says here, volcanoes with thick lava trap the gas bubbles. Eventually, the gas makes the volcano explode. In the activity, they saw that the lava gas bubbles get trapped, which makes it explode. So once again, these mountains where the lava comes up and gets trapped and trapped and trapped because it's so thick, those are the ones that explode, as opposed to the ones that are thinner. They don't trap the gases as much, and it just kind of just pours out over the surface. Okay, well, keep an eye out for the assignment today, and I look forward to talking with you again tomorrow. Bye-bye.